Ok, physics again. En este caso vamos a buscar in the circuits which data is missing. So let's first enlist in the data that we have. Okay, so data. We know the voltage, which is 110 volts. We know the resistance, which is 20 ohms. We're looking for the current. So how do you find current? Simple. Current is equal to voltage divided by resistance. So current will be 110 divided by 20. If I do that, it will give me 5.5 amperes. And that's it. Next. Okay, this is another circuit. In this circuit, we know the current, so we're not looking for the current, 13 amperes. We know the resistance, which is 28 ohms, and we're looking for the voltage. How do we find the voltage? Well, voltage equals current times resistance. So voltage will be 13 times 28. If I multiply that, it will give me 364 volts. And that's it. Next, we are looking for the resistance now. We know the voltage is 56 volts. We know the current is 37 amperes. And we're looking for the resistance. So how do you find resistance? Well, it's voltage divided by the current. So the resistance will be, in this case, 56 divided by 37, which gives you an answer of 1.5135 ohms. And that's it. So another one. Okay, in this case we have two resistances. Okay, the voltage is 110 volts. We know we have resistance 1, which will be 7 ohms, and we have resistance 2, which is 21 ohms. Now, since these ones are independent one of the other one, they're not connected in succession, but they are independent. They have their independent connections to the main line. That means this is a parallel connection. So we're going to write that we have a parallel connection, and we're looking for the current. So when you have a parallel connection, well, you have multiple resistances. You have to find the resistance of the entire circuit. You cannot work with one then the other one. Like, no, you have to find a single resistance in general that will be used to find the current. So how do you find that main resistance of the circuit? Well, if it's parallel, there's a formula, which will be this one. All we need to do is, well, substitute. So the resistance 1, which will be 7, times resistance 2, which is 21, divided by the sum of them. So 7 plus 21 is 28, so I'll divide with that. Okay. If I do those operations, I'll get 5.25 ohms. That will be the resistance of the circuit. Now I can use it to find the current. Current is the voltage divided by the resistance of the circuit. So the current will be 110 divided by 5.25. The current in this case would be 20.9524 amperes. And that's it. Okay, next one. We have also two resistances, but they are plugged in one after the other one. They're basically plugged in sequence. So that will be a series connection. Let's get the data first. Voltage is 210 volts. We know resistance 1 will be 14 ohms, and resistance 2 will be 16 ohms. We have a series connection. And we're looking for the current. So in a series connection, the resistance of the circuit can be easily found by just adding both resistances. So resistance in this case will be 14 plus 16, which will give us 30 ohms. Now that I know the resistance of the circuit, we can find the current. Current is voltage divided by resistance. Current will be then 210 volts divided by 30 ohms. And that will give us an answer of 7 amperes. And that's it. So that's how you solve basic circuits. That will be it.